Aloha and welcome to our video on weathering. In this video we'll describe what mechanical weathering is, we'll explain what chemical weathering is, and then we'll identify the factors that affect the rate of weathering. Okay, so the first thing we're going to talk about is mechanical weathering. And mechanical weathering is quite simply breaking rocks into smaller pieces. There's no chemical change going on, the rocks are still the same chemical composition. The only difference is they've gone from one big piece into a bunch of little pieces. Now there's three processes that we'll look into that cause mechanical weathering. The first is frost wedging. Now frost wedging is when you have a little crack in the rock, which we can see over here, and it fills up with water. Now if it gets cold enough, that water will freeze, and as it does so, it expands. And you've seen that if you take a water bottle, stick it in the freezer, and let it freeze while it's full, it'll expand and distort the plastic. Well, the same is true here in this rock, is it'll expand out like that, and as it does so, you'll notice that the crack's going to get a little bit larger. Now that crack will fill up with water again, and it'll freeze again, and this will happen over and over again until ultimately it breaks through the rock. Now this can take years, or it can be depending on the time, but it's a repeated process. It's not going to happen just once. The next is unloading and exfoliation, and you can see an example down here. That's if we have this uplift of igneous rock. So we had igneous rock that was buried and it gets thrust up above the surface and now it gets exposed to the elements. And this is where weathering can start to happen. What we'll notice is that it will expand a little bit as it's being uplifted, but also you end up with these layers breaking off. And it's kind of like the peeling an onion, so to speak. So that's why we call it exfoliation. You're peeling off these layers. Now the final one is biological activity. And biological activity primarily is going to be with plants, but it can also be animals and things like that. Anything that's breaking up rocks. So if we start off with our rock, notice there's a little crack in the rock here, and a seed can fall in there. If the seed sprouts, then we get a plant growing, and its roots are going to work its way through the crack, and ultimately they can split the rock. So we can see that all we're doing here is taking one rock and breaking it down into smaller rocks, and that's what mechanical weathering is all about. Now, chemical weathering is going to be a little bit different. In chemical weathering, what we're doing is we're transforming the rock into something new. Okay, we're causing a chemical reaction to occur. So we're not simply breaking a rock smaller, we're actually changing the composition. Perhaps the most common way for this to happen is the use of water. And when we're talking about water, we talk about acid rain. So what will happen is in the atmosphere, we're releasing out carbon dioxide. And that carbon dioxide gets into the atmosphere and it'll join up with water that's out there. And it can happen up here in the clouds, or it can happen down here on the ground. And what happens is the carbon dioxide and the water join together and they form carbonic acid. So it's a real weak acid. But that carbonic acid will react with dolomite, and it'll react with limestone, it'll react with marble and things of that nature, and it'll actually cause it to erode or chemically change. You'll change the nature of it, it'll get washed away and things of that nature. So we notice that the rocks are breaking down. Now, when we talk about chemical weathering, another one that we like to bring up is this spheroidal weathering, and you can see an example here. And what that is if I took a square, a cube of a rock, and I put it out and exposed it to the elements, the edges here would erode quicker. And if we erode away all the edges, what we end up with is going to be that spheroid type rock that you can see right over here. So the lesson will go into these a little bit more in detail. I just wanted you to get an idea of what it was all about. Now the last topic they'll talk about in the lessons is going to be this one here, things that will affect the rate of weathering, how fast this weathering occurs. Now if I have one big rock, we're going to get very little chemical weathering on there. It'll just happen on the surfaces. But if I can take that big rock and break it down into smaller pieces, then I'm increasing the amount of surface area, and that'll allow chemical weathering to occur a little bit quicker. So with mechanical weathering, what it does is it increases the surface area. Now it'll also increase the weathering and erosion under mechanical means, because if you break it down into smaller pieces, it can get broken down a little bit easier. The other things that will affect it are characteristics of the rock that's being weathered, its composition, what it's made of, and the conditions that it's found in. And also climate. Climate kind of plays back to this one as well. So in the lesson, they'll go through those and explain them a little bit more. But simply, if it's something that's durable, it's not going to weather as quickly as if it's something that's kind of brittle or frail. And then we have differential weathering, and we see a lot of that here. Here we can see a chimney column over here in Bryce Canyon, but you can see how parts of the rock have eroded or weathered away faster than other parts. And that's all we're talking about when we talk about differential weathering. Okay, so that's it for this introductory video. As always, good luck on the lessons, and we'll see you in the next video.